so we're going to look at grouped frequency tables. So we did frequency tables yesterday, so this is grouped frequency tables. Today is the 1st of December.
Yeah.
Okay, and we're going to say find the mean actually find the estimate of the mean for the age of cats. Okay, so we're going to have a table. We've got the age, and then we're going to have the frequency. Frequency. So what does this all mean?
This looks familiar. Oh, we did, whoa. We did this with Miss Checker.
Yeah, you'll have done it before for sure.
Yeah. Yeah, we did this at M1, but I don't remember the this. So I would assume, right, when you're finding the estimate of the mean, you just get you assume that you take the mean of the range and then multiply it by the frequencies for each one, if that makes sense.
The mean of the age?
So I'm saying, like when the frequency is 0 to 2, you just assume it's 1.
Okay, and then what about for the next part?
And then you for 3.
Okay, so it's not, yeah, so we don't think of it as the mean, we think it more of the
middle,
the midpoint, yeah. So the midpoint is going to be 1, 3, 5, 7, and then we proceed as before. You know, if you were going to do this out, you would do your frequency times your midpoint. Yep. Find the sum. We'll just quickly do it. Frequency times midpoint, so it's 2, 12, 15, 7. So the mean is equal to 2 plus 12 plus 15 plus 7 divided by the total of the frequency. 4, 5, 6, 7, 8, 9, 10. And we get 3.6 for the mean. So the mean estimate for the mean age is 3.6. Why is it an estimate?
Because we don't know the exact values of the...
Right, because we don't know the exact values for the ages. Okay, and then we're going to do it on the calculator.
So wait, I'm
yeah, go for it.
The frequency of the...
Okay. All right, so on the calc, it's exactly the same type of thing, okay? We do it the same way, except, actually I want a new doc. Nope, don't save. Lists and spreadsheet. Okay, now I'm not going to put in the class intervals, okay? I'm going to put in the midpoint. So 1, 3, 5, 7. Then the frequency 2, 4, 3, 1. All good. Then we go to menu, statistics. Which one do I go to?
One variable statistics.
One variable. Number of lists. 1. What goes in X1? That should be A because that's my frequency list is B. We want our results in C. And we can see then X bar, our mean is 3.6. Okay. Easy enough?
Yes.
Excellent. Okay, so there's plenty of practice on this on page 292. Okay, now we're not going to do that now because I really think this is this is basic, yeah, this is easy enough, yeah?
Well,
So, yep.
When would you ever need the sum of all of them squared?
To work out the standard deviation, which we will get to, okay? Which we will look at now.
And ANOVA testing.
Yeah, but we're not going to do any ANOVA testing. Or ANOVA. Okay. So, page 292, you do need to look at these, okay? I may give you a test at some point on how to do this, okay? And you need to know how to do this. So our next title is Measures of Dispersion. So what do I mean by measures of dispersion?
How far away something might be from the middle or average?
Yeah, good. So that's a good way of saying it. We can also think of it as how spread out the data is. So there's different ways that we can do this. There's different measures of dispersion. Easiest is probably what? Nope, that's probably the hardest.
Error bars?
Nope. What's the one that you always learn in M1 and M2 and M3?
Oh, outliers?
Nope.
Anomalies.
No.
Oh, like
That's
inside
got nothing
the
to do with
Quartiles.
Okay, even easier than that.
The range.
The range, right. The range is a measure of dispersion. Okay, and the range is the
range. I don't know how else to say it. The group, the max value to the minimum value.
Yep, max value minus the minimum value. Okay, and of course on the calculator, you are told what the max value is and the min value is, okay? Of course it's, you can just look at the data and read off what the max and min is, but it does give you on the calc, just in case you're having a moment. Okay, the second one is the interquartile range, which we denote by IQR. How do we work out the interquartile range?
I think it's the upper quartile minus the lower quartile.
Yep. So Q3 minus Q1. And again, on your calculator, you're told what Q3 is, you're told what Q1 is, okay? So you don't even need to work these quartiles out. Yep.
So quartile, 4.
Yes.
Why are there not 4 of them?
Well, no, it's because if you think you've got your data and it splits your data, so imagine this is my Q2, this is my median. Q1 is the first quarter of the data, okay? Then Q3, so there is 3 kind of quartiles, Q1, Q2, Q3, but it splits the data up into 4. Okay, good question.
So it was in Q1.
Mm-hmm.
So I'm confused about this labeling now.
Yeah?
Q2 is always going to be the median?
Yeah.
Not the average.
Q2 is an average, like the median is an average.
An average doesn't mean mean. A mean is a type of average.
And the mean is a type of
Q2
average.
Q2 is the median, not the mean.
Exactly.
Yeah.
Okay.
Yeah.
But so all right, I get it.
So, and remember, Q2 is the median, and that means the first, like you're taking exactly the middle value, yeah?
Okay, but is Q1, this is quartile 1, obviously.
Yeah?
What? This is the entire quartile range.
Say again?
This is Q1.
Yeah.
This
First
is the
25%.
This is the interquartile range.
Yeah.
And then this is Q2.
Well, no.
Think of them as points.
No, think about it as, this is your first 25% of your data lies in here, yeah?
Yeah.
The first 50% of your data lies in here.
Yeah.
That makes sense because your median is the middle value. So first 50%. First 75% lies in here.
Yeah.
Okay? Up to your upper quartile. And then you've got your 100% of your data.
Okay, so if I was to do the, I don't know why I'm not understanding this. If I was to do the interquartile range,
That's going to give you how much of the data?
well, what am I actually subtracting? I'm subtracting
You're doing Q3, take away Q1. So you're doing that one, take away that one, which gives you how much of the data? 50% of the data. Okay, it's 50% between 25 above, 25 below. Yeah, it's kind of giving you that
I
spread.
think I was confused because so from the Q3 line to the end of the line, that's not the third quartile. Like that range.
This is your upper quartile.
Think of it as a line.
Okay, so it's just a
point.
It's a
Yeah.
point. I thought it was the range.
No, it's just a point.
Wow.
Okay. We'll come to outliers in a second. Okay, third one is variance and standard deviation. Now, we're going to look at standard deviation and variance. So the variance is the standard deviation squared. Okay, so if we know the standard deviation and we square it, we get the variance. Now what is the standard deviation?
The distance. I think it's just how far away.
Yeah.
Something is from the average, or from the mean.
Oh no. Sorry, I just forgot to do something. Okay, standard deviation tells us, yeah, you're right. How far, on average.
By the way, you never gave me my cookie.
Oh no, I didn't. Tells us how far on average each data point.
I'll take a 6 on the next test as a recuperation.
Is away from the mean. Okay, so the standard deviation tells us how far on average each data point is away from the mean. So it's kind of like the mean of the mean. Okay, and to show you how we work out the standard deviation, let's do an example. We'll do it by hand. I've never seen them ask a question and get you to do it by hand. It's always using the calculator, but just in case. Find the standard deviation of, let's say, 1, 3, 7, 9, 10. 60. Now, the standard deviation, I should have said up here, sorry. So the standard deviation is denoted by that symbol, which is called sigma. It has the same name as that, yep. These are the same thing, except this one's capital sigma, this one is lowercase sigma. Okay? So your standard deviation is denoted by that. Now to calculate the standard deviation, this is probably in your formula booklet, it's the sum of x minus x bar all squared over n. Okay, doesn't look very nice, but actually
X? The number of
x is your data points. Okay,
the number of them?
No, not the number. N is the number. Okay, so for example, if I set this out, if I was going to work this out, I'm going to do a table. And doing a table to work out your standard deviation is the easiest way to do it. So I've got 1, 3, 7, 9, 10, and 60. Then I'm going to work out what x bar is. So work out what x bar is for me.
By hand?
Yep. 1 plus...
15?
Is it?
14.8.
Divided by how many? 8.6? Is it 14.8 or 15?
I said 15. I don't know.
90 divided by... Oh, that works out.
No, you're right.
Okay, cool, nice. That was nice. Okay, so my mean is 15. So our formula says we need to do x minus x bar, okay? So 1 minus 15 is negative 14. 3 minus 15 is negative 12. 7 minus 15, negative 8. 9 minus 15 is negative 6. 10 minus 15, negative 5. And then 60 minus 15 is 45, yep. So that's x minus x bar. You all with me?
Yeah.
All right, so we're interested in, just to kind of go back to what standard deviation is, it's how far on average each data point is away from the mean. So this data point is 14 places away from the mean, yep. This one is 12 places away, but it's negative. And what we want to do is to find the average distance they are away from the mean, okay? But the problem is, if I was just to add these up, these negatives are going to mess things up because it's going to cancel stuff out. So that is the reason why we are having to square them, okay? So we're going to square each of these values then. (14 squared) 196 144. So that gets rid of the negatives. 45 squared 225. Okay. And then all we need to do then is to find the sum of them, okay.
You forgot to write the square sign.
Oh, thank you. Have you added them up, Nick?
Yeah.
What did you get?
2490.
2490. So, our standard deviation is, and I've done this wrong as well, so just give me a second. 2490 divided by 6. I will, sorry, I've just done something. I've made a boo-boo, but it's not a major boo-boo, so don't worry. Our standard deviation is actually equal to the square root of that, okay? My mistake, okay, that is our formula. Standard deviation is equal to that. So we put that in, square root. Of 2490 divided by 6 gives us 20.37. Yep.
Shouldn't it be 20.4?
So 3 sig figs, 20.4. And you're absolutely right. We should do everything to 3 sig figs unless otherwise told. Now the variance, we said, is the standard deviation squared. So this is how we write the variance. It's just sigma squared.
Sigma squared.
Yeah, because this is, which is 415. So that is our variance. Is that okay? Nicholas, is that okay? Okay, right, all good? So on the calculator, just to show you how you do this, because you will more than likely have to do this on the calculator, but it's exactly the same thing. Yeah, but we need to make sure that we're picking the right one. So I'm just going to put them in 1, 3, 7, 9, 10, 60. And we want menu, stats, static calc.
You can do the Vernier thing on here. Yeah, if you put a new document, it's the last one says add Vernier data plus.
Okay, so we need to make sure that you're picking the right one. Okay, so we're given x bar is 15. Okay, and then down here on the calculator, this is our standard deviation. Okay, 20.3715. So sigma x is the standard deviation. Do not get it confused with SX. Okay, that's something else.
What is it?
It's the sample. It's the sample standard deviation.
How do they sample? What's the sampling?
So, okay, well, let's have a quick chat about that. So, let me just write down. So, on calc, we use sigma x, okay? Very, very important. Now, our formula for the standard deviation. I'll just quickly write this down. I guess this is not something that you need to know for this course. You do need to know it for the AI course, but not for this one. But it'll do you no harm. It may become useful. The formula for is for the assumes. Okay, listening? Oi. The formula that I've given you for standard deviation assumes that we are using population data. Okay, so if we're looking at a population, this is the formula that I would use, okay?
Why would you use something different?
Because you need to account of the fact that you're using a sample. Your sample standard deviation is going to be slightly different to your population standard deviation.
Okay.
But so the formula I've given assumes that we're using population data. If we are calculating standard deviation for a sample, we use the formula, and this is where it's interesting. So we use the formula sigma equals square root.
Can you just call it SD? Is that?
No. And the difference is it's over n minus 1, okay? Now this is for a sample. But do not, this is not on the course, okay? You do not need to be aware of this. This is just for interest's sake, okay?
I'm going to end up messing this up. This is not very interesting.
And on the calc, this is the SX, okay? So whenever we put this into the calc, so where's my calculator? So here we've got sigma x, okay? This is my population standard deviation, yep, 20.37, which is what we worked out. This is us assuming that it's a population that we're taking this data from, okay? This is like saying that's all the data, okay? There's 6 pieces of data, that's it. However, if we're assuming that these 6 pieces of data are actually a sample from a population, the standard deviation is 22.3, okay? Is this one. But for what you're doing, for what you need to know, you're just using this value, okay?
Is it?
You do not need to worry about this at all, okay? So please don't just ignore that.
Is it because a sample is less likely to include outliers, so the standard deviation is more likely to be like a sample standard of deviation, if you think about it, would never be naturally more. Because think about it. If
you can do that, is that chapter finished? Okay. So you can do questions on page 307, 309, and then the review on 311 up to 313. 315. Okay, so we can make a start in some of those now, and then we're going to move on tomorrow to the next part, which is the more interesting stuff.
I am starved.